Today's lesson deals with finding segment lengths in circles. In the past, we've been dealing a lot with angles in circles. Now we're dealing with segments and their lengths. So don't try to focus on that angle is half the arc formula anymore. These are different formulas we're going to be using today. First up, let's go through some of these main terms. Segments of a chord. Whenever segments intersect each other, they make other little segments too. So as you can see, this chord intersects this chord, and it creates a lot of different segments. There's 1, 2, 3, 4 smaller parts now in that picture. This has a bunch of different parts too. There's one out here, there's one over here, and that's created by this intersection with the circle, and then there's a third out here. So some of these have some special names. This one total piece right here that puts together 1 and 2 is called a secant segment. This one right here is called a tangent segment because it's tangent to the circle. This is a secant segment because it touches the circle at 1, 2 points and keeps going. And then there's a third term right here, external segment. External meaning what? Outside. So which pieces are outside? Oh, these over here. These over here are examples of external segments. There are 2 external segments out of all those in these 2 pictures. Now it's time to talk about an important formula that we're going to be using with these circles. Now I drew a picture earlier that has 2 chords that intersect inside the circle, and that's what you're seeing again here, and they use some letters this time. So here is the formula. Please focus on this. EA times something equals EC times something. Did anybody figure it out? What goes in this first blank? EB. Well, where is EB? AE times EB. Oh, it's the 2 pieces that are made whenever it's bisected, or not exactly bisected, but intersected. So whenever one chord is being intersected or cut, not exactly bisected, those are the 2 pieces that are going to be multiplying by each other. Same thing for the other chord. Whenever it's chopped into 2 separate pieces, those are the 2 pieces we're going to be multiplying. So there's EC times the other piece that's left over, DE. Now there's a little phrase that kind of sums it up a little bit. Some people like it, some people don't. I'll go ahead and give it to you. And write it out either in the side or down below this box. I'll do it down below this box. Point to circle times point to circle. And I'll show you what that means. Point to circle times point to circle. I'll be saying that a bunch, and this little phrase will help you remember what to multiply on all these different figures. So look back up here. Whenever it says point, that means the point where the chords cross or touch each other. So that's going to be where E is. That's where we make a bold point. So what I need to do is go from this point until I hit the circle. What segment is that? That is EA or AE. But now I need to stay on that chord and finish it out. So I got to go back to point to circle. Point to circle. So what I just did is I did point to circle times point to circle, which is this phrase right here, and now I've just taken care of this part of the formula. For the other chord, I did the same thing. Point to circle times point to circle, and now I've finished out that chord, and there's the other part of my formula. This is going to work for all these types of problems, even when we have an external segment like that. I go point to circle times point to circle and point to circle times point to circle. And we'll emphasize this later. This other one's a little bit tricky for some people. Now we're going to apply that little theorem or phrase to this problem right here. So what I like to do is focus on one chord at a time. So I'm looking at LM. I notice that it's chopped by that little point right there. And I like to do point to circle. So point to the circle. I like the short distance first. How long was that one? That's x plus y. So I'm going to write it out here. X plus, 1. And that's going to have parentheses around it because that's a group of terms. Now after I've done one point to circle, I need to finish out the whole chord. So I got to go the other direction. Point to circle. How long is that one? That's x plus 3. I just finished out that chord. I wrote down both of those separate segments times each other over here to the side. Now I'm going to go to the other chord, but to be able to go to the other chord, I have to write equals first. And now I can go to the other chord. I go back to that point, and how far is it from the point to the circle? It's x units long. Sometimes they give you a number, sometimes they don't. I don't really have to use parentheses there because it's just one term. But I need to finish out this chord. So I just did this little piece. Now I need to go the other direction. And that other direction is x plus 5. And that should be in parentheses because that's a group of terms. From here, it's just algebra. So one problem that I've seen from geometry students in the past is how to deal with this part. Usually everybody's good over here. This part isn't real hard. But this part on the left, some people forget how to do it. Does anybody remember the key thing you're supposed to do? FOIL, good. I heard about half of you remember that. So x times x, that's the first term, that's the f. So x times x is x squared. Then x times 3. I like to think of this as repeated distribution. I'm distributing that x to both terms. X times 3 is 3x. Now I'm done distributing that x, and I got to move over and distribute that 1. 1 times x is 1x, and 1 times 3, plain old 3. Similar process over here, except we're just distributing one term. X times x, x squared. X times 5 is 5x. So now the challenge is to solve this for x. Sometimes it's easy, sometimes hard. Does anybody know what to do first? Combine like terms. So I see that these are like terms. They're both my x terms. So 3x's plus 1x is 4x's. And I'll show a lot of steps here. Some people don't need this many steps, but I'll show them for today. Anything else we can do? Okay, I like to deal with the term that has the highest exponent, it's in the highest degree, and that's my x squared term. Can I move one of those? Okay, does it matter which one I move? It actually doesn't matter because they have the same value. Usually we move the smaller one, but since they're both 1x squared and 1x squared, it doesn't matter which one I move. To get this one to the other side, I just subtract 1x squared. So when I have 1x squared and I subtract 1x squared, what happened on each side? They canceled. So now I'm left with something simple that everybody should be able to solve from here. What should we do now? Subtract the 4x because it's the smaller of the x terms. We're still focusing on the higher degree term. So that one's gone. 5x minus 4x is 1x, or just x. And we get x is 3. Have we answered the question, though? No. So that's a bit of algebra. Some people can skip some steps, but that's just to get x. The question says find the length of ML and the length of JK. So all we need to do is take this value and do what with it? Plug it in. So let's find those pieces. ML is this total length, and JK is that total length. So a lot of this we can do in our head. If we plug that 3 in right here, what's 3 plus 3? 6. And then I'll just write that out to the side. And then down here, if we plug in 3 plus 1, we get 4. So what's its total length? 6 plus 4 is 10. JK is pretty much the same thing. 3 plus 5, 8. And then just an x, so that's 3. And 8 plus 3 is 11. So the lengths of those two chords are 11. It's not saying that they're equal. So some people think, they should be equal. This is not true. This is not true. They're not equal chords. So be careful there. Here's one of the other situations that you'll see. So this time we have two secant segments, no tangent segments. And on this one, we have to think of kind of a different way of doing these. However, our good old phrase that we did in the past works out really well. Point to circle times point to circle. First off, I'll show you what the letters are, and then we'll think of it in terms of point to circle times point to circle. EA is what they mentioned first. I went from the point to the circle. Am I done with that whole segment, though? No. I need to go back to the point and then travel over to the circle again. So if I go back to the point now, how do I hit the circle again? I have to hit EB. So first I did EA, and then I did E over to B. That bottom piece, as E, C, and D, is pretty much the same. Point to circle is how long? EC, and that's written down. But now to finish that part out, what do I need to do? I need to multiply by E all the way to D, point to circle. Point to circle times point to circle really helps out if you understand what's going on. This problem is a really good one. You will see this on the test. So you can think of it like this. Something times something equals something times something. Pretty much all these problems today are going to use this basic formula. You just got to figure out what's being multiplied in each of those spots. So in the problem, we got to go out to the point of intersection. And I usually do the top segment first. So I go from the point and tell me when to stop. Oops, y'all missed it. You're supposed to stop at the circle. That's why it says point to circle. So point to circle is how long? 6. Now I got to go back to the point. What distance do we need to do now? R to P. How long is R to P? 10. Point to circle times point to circle. So that's 6 times 10. Similar process for the other one. Tell me when to stop this time. I go to the point. Tell me when to stop. All right. So we stop on the S. You stop when you hit the circle. So that's a 5. Now I need to go back to the point. What distance should I do from the next part? RT, good. How do you write that total distance, though? It's not 5 times x, it's 5 plus x, or x plus 5. You put those together. Earlier we did 6 plus 4, we add them, same thing down here. 5 plus x to get its total length. A little bit of algebra. 6 times 10, 60. And what are we supposed to do when we have a number outside parentheses? Distribute. So that's 5x, and then 5 times 5 is 25. Couple steps remaining. Subtract 25, what do you get? Yeah, 35. Divide by 5 and you get 7. Have we answered the question? It says find the value of x. Did we find the value of x? Yes, it is 7. We're done right there. Go down and try these checkpoints real quick. See how you do. All right, here we go on these. Whenever they're inside, you need to remember that you're not going to be adding anything. I saw a lot of people trying to add stuff, and that's how people messed up. But here's our basic formula. Something times something equals something times something. Point to circle times point to circle is the thing we need to remember. So if I go, here's my point of intersection. Point to circle is how long? 5. Point to circle to continue out that chord, I get 12. Now I got to move to the other chord that's over here. Point to circle is how long? 6. And finish out the chord, point to circle. That's X. Some people were trying to add stuff up here, and that's how they messed up. 5 times 12 is 60. 6 times X is 6X. Divide by 6 on each side, and you get X is 10. That one should be pretty simple. Anytime they're inside like that, you only have one variable, it should be pretty straightforward. This one's definitely going to be more challenging because we have some external segments. Anytime you have external segments, you're going to have some addition. But it's still using the same basic formula. It's just a little longer. I like to do the top segment first, so I'll start here. Point and stop when you hit the circle. How long is it? 6. But now I need the total length of that whole secant segment. So that goes from the point all the way to the other part of the circle. How long is that total piece? 6 plus 8. Yeah, 6 plus 8 is 14. I got to do that same process for this other secant segment. I go point and stop when I hit the circle. That's 7 units long. But then I need point all the way to the circle. That's our total length. So that's X plus 7. And that's a group of terms, so it goes in parentheses. I didn't use some parentheses over here because it's just adding 2 integers. 6 times 14 is what? 84, thank you. 7 times X is 7X, and 7 times 7 is 49. Subtract 49 from each side, and what do you get? 35, thank you. Divide by 7, and you get 5. Here's the last type of problem you should be able to do. Now, the only special part of this one is you should notice that it doesn't have 2 secant segments. It has a secant segment and a tangent segment. So here's our tangent piece. Anytime you have a tangent segment, you have to square the tangent segment. So write that out. That's our tangent segment. You have to square that tangent segment. You have to square that tangent segment. Because our little phrase says point to circle times point to circle. You have to multiply 2 things. Since it doesn't hit the circle at 2 spots, it only hits it once, you have to multiply by itself. So point to circle times point to circle. So that's doing it 2 times, or just squaring itself. And then the other part is just how we did earlier. Point to circle is EC, and then the total. Point all the way to the circle. That's ED. Let's apply that to this next example. I like to start with the tangent segment. The tangent has a 14. Point to circle times point to circle. So that's 14 times 14, or 14 squared. And now I'll move over to the secant segment. Point to circle is how long? X. Times point all the way to the circle. That's that total piece, which is X plus 12. Since that's a group of terms, I use parentheses. Anytime you have an X on an external piece, it makes it a little more challenging, but it's still doable. Does anybody know 14 squared? Yeah, 196. The other part we need to distribute. X times X is X squared, and X times 12 is 12X. Now, this is tricky for some people because algebra's gone a long time ago. So what you need to do actually is solve, get everything on one side. So we got to move this 196 over with the other terms. So now it's going to look like this. X squared plus 12X minus 196. From here you have 2 options. You can factor, which is the opposite of FOILing, or you can use the quadratic formula. So what we're going to work on here is just the method of factoring, because that's something they expect you to know in Algebra 2. So we need to factor this. Anytime you get 0 on one side and you have an x squared term, an x term, and a plain old constant, you should be able to factor. And if you can't factor, you can do the quadratic formula. So what we need to remember, factoring looks like this. You're going to have a binomial times a binomial. And inside, we're going to have, since this is a plain old x term, we're going to have x as our first terms in our binomials. So they made it easy on us because that's just a plain old x term. Whenever they put a number in front of that x squared term, it gets a little more challenging. So we're not ready for that yet. Let's just do this. All right, so here's the next part you got to remember for math. I need two numbers that multiply to be 196 and add to be 12. So a lot of times in Algebra 1, you're taught to pull out that 196, and it is a negative. That means in the end, you're going to have a positive number and a negative number that multiply to give you that 196. So a positive and a negative. But don't worry about that negative yet. Let's just list out numbers that multiply to be 196. So I always start off with basic. Since this is even, it's divisible by 2. 2 times what is 196? 98. Next, tell me, does 3 divide into 196? So type in your calculator. 196 divided by 3. No. All right, divide it by 4. 4 is divisible. All right, so what's that? 49. Is 5 going to go? No. Is 6? Type it in. 7. 8. 7 is 28. 7 times 28. What about 8? Does it go into it? Try 9. 10 doesn't. 11. 12. All right, so let's pause here. Oh, 14 does? 14 times 14. All right. Yeah, we should have known that. That's how we got that number. All right, let's see if any of these number combinations can add or subtract to be 12. Can these two numbers add or subtract to be 12? Nope, no combination, positives or negatives, can work out. Can these add or subtract to be 12? Can these add or subtract to be 12? Can these add or subtract to be 12? No. So here's what this means. This means that this one is not factorable. A lot of times, it will factor nice and neat, you're done. But this one does not. So we have to use this formula, the quadratic formula, which is right here. So this formula says negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. That's the formula we're going to plug into. And here's where those a, b, and c terms come from. This 1 is your a. It's the coefficient in front of your x squared. 12 is your b. And negative 196 is your c term. We're going to plug those into that quadratic formula. So this is just substitution. If you're good with the calculator, you'll be fine. B goes in first. It says take the opposite of b. So if this is a positive number, I'm going to write down negative 12. If it was a negative, then I'd write down positive 12. And then we have plus or minus the square root of that b term squared. Well, what's 12 squared? 144. Minus 4 times a times c. What's our a term? That's 1. And our c term is negative 196. All over 2 times our a term, which is 1. So this is just calculating now. There's no simplifying out here. However, you can simplify a lot under here. So if I was good on a calculator, here's what I would type. I would type in the square root 144 minus 4 times 1 times negative 196. Tell me what you get there. It should be kind of big. Say it again. Somebody verify that, 30.463. So they already took the square root, so that square root's gone. 30.463. Now, since this is 2 times 1, we can do that real quick. That's easy. 2 times 1 is 2. Now, does anybody remember what that plus or minus is going to do to our answer? Yeah, I hear it. It's going to give us 2 answers. So here's what it's going to look like. We're going to do this to show that we're going to have 2 separate answers. We're going to try in our calculator, negative 12 plus 30.463, and then divide it by 2. And then we're going to do the minus, so 12 minus 30.463, all divided by 2. All right. Once you type these in, you should get these 2 values at the end, 9.231 and negative 21.231. Okay, one problem on rounding. This should be a 2 at the end. Be careful on rounding. 232. Try out this checkpoint. It should be very similar to example 3. I'll give you a little bit of time. Here we go. I'm going to go kind of quick on this one. First thing we need to do, find the tangent piece. That's the 8. Point to circle times point to circle. That's 8 times 8, or 8 squared. The other piece is going to be point to circle times point to circle. The external piece usually goes first. That's our x term. And then we need our total. Our total is x plus 6. We add those 2 pieces together. Now we have some algebra. So that's 64. X times x is x squared. X times 6 is 6x. Whenever we have 3 different types of terms, there's no combining terms. We get them all on the same sides because it's a trinomial. So we have x squared, 6x, and a negative 64. We're making sure they're decreasing in order of degree. We then find our a, b, and c. 1 is a, 6 is our b, and negative 64 is our c term. We can now plug into our quadratic formula. Our quadratic formula looks like this. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So make sure all over 2a. And make sure this square root is all over that term as well. Now we substitute in our values. So it's opposite of b first. So it was positive 6. Now it's going to be negative 6. We have our square root term. That's a 6 squared minus 4 times a is 1 times c, which is negative 64. A lot of people forget the negative with that 64. Then it's all over 2 times a, which is 1. From here, we can simplify further by doing the stuff underneath. That's 36 right there. 6 squared is 36. And then this part can all be typed in the calculator. Square root of 36 minus 4 times 1 times negative 64. What do you get for that? 32.24. All right, and then we have our plus and minus, a negative 6, and 2 times 1 is 2. Break it down to 2 problems. We're going to add in one part, we're going to subtract in the other. So that's negative 6 plus 32.24 divided by 2, and negative 6 minus 32.24 divided by 2. Type those in to get your final answers. Sorry, this was an incorrect value. It's not 32. It's 17.088. That's much better. So let's correct these. This is 17.088. And now, complete it from there. After making those final adjustments to that value from 32 over to 17, you can then compute these values to be 5.544 and negative 11.544. These are your 2 solutions to this last problem.